You ever want those super capacity battery packs for your power tools? Today we're going to make them. 6, 8, 10, 12 amp hours, no problem. Want to see how it's done? Keep watching. Wow, that has a ton more power. Yeah, it easily has twice, the tool has twice the power. So if you bought enough tools, you end up having a bunch of these little teeny packs laying around. They give you these little 2 amp hour, 1.5 amp hour packs that really aren't good for much. They're okay for like a drill or something, but if you put them in anything heavier duty, you're going to need a 4 amp hour, 5 amp hour, 5 amp hour pack. You're going to start needing these lot bigger packs. And even these sometimes aren't enough to give you excellent runtime. So then we go to the store and we look at, a 12 amp hour pack, but then you see that they cost $220, $250 just for one battery, and you shy away and you keep just using the stuff you have. So the easiest way to add capacity to, a small battery pack or even a big battery pack is just take these little packs that we don't really use that often and take the cells out of them and use them and combine them with the cells in here. So I could take this 4 amp hour, turn it into like a 6 amp hour. I could take 2 4 amp hours and turn it into an 8 amp hour. And we'll do that today. I can take this 4 amp hour right here and I'll combine it with the little batteries in this 2 amp hour and we'll make this into a 6 amp hour. The other way is you could actually go out and buy your own 18650 cells or 2170 cells. They're 18650, that means 18 millimeters this way and 650 millimeters this way. This is what is all that's in all these battery packs. But you go buy these and they get kind of expensive because you have to buy, for our power tools that we require, we need high discharge, high drain cells. We need cells that can put out 20, 30 amps at a time. These ones right here are out of power banks. Laptop batteries use the same, and these things can only put out 2, 3, 4, maybe 5 amps, and they would just fry in no times if we tried to power our high drain power tools. But anyway, I'm going to go over really quickly how all these things are kind of put together, just real basic, just in case you don't know. This is a 20 volt, 18 volt, 18 volt and 20 volt are identical in every single way. It's just how you market it to the public. So these are 4 volts apiece. And it's just like you're putting a double A in something. You got a positive. Well, you got a positive and you got a negative. Little nipple is on the positive. And so we have 4 volts, 8 volts, 12, 16, 20. That is 20 volts. Now, you'll see that there's that's what a typical battery pack like this is, a single row battery pack. It's just 5 batteries, just like that, whether it's 18 or 20 volts. Now, to get double the capacity, I can take a battery right here and I can join its, well, let's flip it around. Join its positive and negative to here, and then do the same thing and just keep going down, 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 and then we just pull one positive off here, one off here, just positive and negative, and we've got 20 volts still, but I have twice the power that I can dump into the tool. And we can do 3 rows, 4 rows, and you can just infinitely do as many rows as you want, and you're good. So these might look a little complicated, but this top right here, that's all they're doing. It's just, the only difference is they're taking this right here, and where this was connected, boom, connection right there. Where these two were connected, boom, boom, boom. That's all sitting right into there. And then they just have another one stacked right on top of it, and you can see that they're joined. So that's enough talking about those. Let's just increase the capacity really fast in one of these. The 12 volt is the exact same way. This is 12 volt battery. You see 3 batteries right here, and so it's 4, 4, 4, 12 volts, and all they're doing is positive, negative, positive, negative, positive to negative, and just cording in them and wrapping them up and sticking them in this package, just like that. It gets a little more complicated in here because they don't stack them so neatly. Like this battery or these 2 batteries are joined, this battery and this battery are joined, and these 2 are joined. But we can turn this into, we'll just take these batteries, from this littler pack. We'll stick them below here, and we'll take one of these battery packs as well. And we'll turn this 4 amp hour. We'll add another set of 4. We'll turn this into an 8 amp hour battery. That's the ultimate to-go tool. So to take apart these battery packs, you're going to need one tool, and that's pretty much just this. They're security Torx. Almost all the battery packs I've ever seen have these security Torx, just a Torx bit with a little pimple in the middle. And generally you need these longer ones because the short bits you can get have a little shoulder on it and won't let you get in. So you need a set of these long ones. So I'll put a link below where you can get these, and then you can take apart all the stuff you're not supposed to take apart. Is you need to have the same amp hour batteries. So this one is a 6-cell, 2 rows of 3 for 12 volts, and all these batteries are 2,000 milliamps each. They all have data on them. They're all 2,000 milliamp each. They don't have to be the same brand, but 2,000 milliamp each. So that's what I've pulled out of here is this little guy right here. And these are all the exact same. They're actually even the same brand, which is fine. That's good. These are both actually brand new battery packs. This one's never been used, and this one's been used twice. These little battery packs, they just don't work good in tools. They don't deliver enough. One of the reasons for that, real quickly, is because these are, what are these, 20, each one of these cells can put out 20 amps, and so, and same here. So this whole battery pack, though, in one row can only put out 20 amps of 12 volts, where you put 2 rows of it, and now it can put out 40 amps of 12 volts. And if I put another row of it, it can actually put out 60 amps of 12 volts. So you'll never get that, when you're really digging the tool in, you'll never get that low voltage where the voltage drops so much that the tool shuts off, and then you're able to shut it off and you turn it back on. So much less likely when you add even more cells. And that's why they like to do multi-cell packs. But we'll just desolder this all, and you can see over 12 volts, it's just a straight line. You can see here that they do give you extra wires here. We got our positive and our negative over here, and if I put a multimeter, you'll have 12 volts across these. But you have a connection in the middle so that the charger can balance charge this cell right here, so it can balance charge this cell, and it can balance charge this cell. So one of these tabs, these ones are already tabbed together. I'm going to have to pull off this tab because I need these batteries to lay flat. So I'm going to reuse this tab as my solder. If you just get some pliers really close, you can just rip them off. Now, I know you'll read online, never solder on these cells because it damages them if you don't put too much heat in them. And especially if you're just quick, these things get hot to the touch while you're using them. If you're just quick, you'll be just fine. So we're going to solder this tab on. It was like that angle. We just need it so the batteries kind of lay flat. And pretty quick and easy to solder them. The very first thing you want to do to actually solder, if you're from the UK, is you want to scratch it up. So we'll get something, there's my knife, and we'll just kind of scratch it up. Otherwise the solder doesn't want to stick. Maybe we'll get a file. We'll just kind of scratch up the surface, and we're going to tin it first. So we're going to apply a little bit of solder to it, and then let it cool. And then we're going to apply a little bit of solder to the thing that we want to also solder, and then we're going to apply them together, apply the heat, and we'll be done. So I'm using electrical solder, and I'm using some paste flux. Paste flux, I like using the paste flux because it allows you to be faster. You want to be in and out and done. You don't want to be putting too much heat. I'm going to get my soldering iron hot. Bring it down till everything liquefies. Let it cool. And we have a bond. Trying to put the tab there, I mean, I can put my finger on it. It's not, I didn't put that much heat into it. Trying to put the tab there and then trying to feed solder in, you're going to overheat the little thing. Just finishing up. Got the majority of it wired. Got one wire left. Just thought I'd show you kind of the technique. I'm using 16 gauge wire. You could use 18, 16. That's about what, I'm just kind of going by what other wire they have on here. And put a little paste flux on this wire. So I pre-tin that, and it'll come over here, and I left, see how fast that tins with just, you scuff it up. That's about it. I'm going to be careful that I don't put this somewhere I don't want. That's all the heat I had to put into it, just split second. That's it. There we go. That thing, whole thing should be wired up to be 12 volts. So it would be like that. This goes on first, but I need to make a filler in here to fill up this gap. I need to make sure, another thing is when you're doing these wires, make sure there's plenty of room for them. And so I made sure I routed them in spots where there wasn't anything. But now I pretty much, I mean, you could even just wrap that with electrical tape and just put longer screws. That's about all you need is longer screws. These are about 3/4 of an inch or 18 millimeters is what it adds. And so if you just put in, got 18 millimeter longer screws, 3/4 of an inch screws, you'll just be able to screw them back up. So you'd wrap that, but with black electrical tape, you'd be never able to tell, but we'll see if we can get some sort of black plastic or something in there, kind of frame it in a little bit better. So I made a little spacer, and I just cut it 3/4 of an inch, and then I just plastic welded it together, just out of, it's like out of a 5-gallon bucket, just the plastic from that. And so that should give me a nice clean look all the way around versus just wrapping it with tape or something like that. So let's see. This should all be good to go if we can get this in there and where it needs to be. And I got my longer screws. They're a little thicker than the original, but that should be fine. Just barely. Just what I had laying around. There we go, from a 4 amp hour to a 6 amp hour. I have to rewrite the sticker on there. Looks great, unless you're really looking at it. Should be just as robust. Let's try it out. Yeah. I mentioned how much I hate the Milwaukee. I hate their this grippy thing. I think it's the worst design ever. I think they should have slide-on batteries on the bottom so that the handle's not so stinking fat. You know, look at this. This is ridiculous. I like the Milwaukee tools. I just hate their 12 volt. The grip on them, the ergonomics on their tools are so bad. You pretty much just grab it with 2 fingers. Your other fingers are kind of just there for support. You can't get a good grip on their 12 volt tools. But there we go. Now let's do an 18-20 volt one. Now we're going to combine 2 larger packs to make an 8 amp hour pack. I have a 4 amp hour pack, a 4 amp hour pack. Exact same brand. So these are Porter cable, but I mean the Makita, the Milwaukee, the Dewalt, they're all the same. You just have them laid out. These ones are simple. Essentially all we do is cut off the top of this and just stick it to the bottom of this one. Yep, just like that. And you can see I might be able to get away with just bridging that solder gap. I might have to add something to it. To make this a clean install, what I decided to do, rather than just solder, you know, I can just connect them up like that. They're essentially touching, but then my case isn't very nice. So what I'm going to do is leave this one in the bottom case, cut off the top of this case, leave this one in this case, and just, you know, essentially glue the case together, weld the cases together, by cutting the top of this off. And so when able to do that and then connect them, I'm going to have to solder these up later. So what I'm going to do is actually connect wires to here, here, to these 6 points, and actually pass them up through little holes. So I've been marking, and so then the wires will come up. I can set that down, and then I have all the spots right here where I can connect the wires to, you know, 1, 2, 3, 4, 5, 6, and then I can put the top on. Took the Dremel, cut off what I needed, so I no longer need that, and then I just mounted it to the bottom of one of them. So I started plastic welding it in place, but I will still, so it's nice and rigid. This stuff is just ABS. Plastic welds really nice. I have a whole video on plastic welding if you don't know how to do that. There we go. Got all of my wires tucked on. I did 18 gauge for these balance charge wires and 16 for my main ones. Okay, I did put a little shoe glue around in there. If you don't know what shoe glue is, this is it. It also goes by the name of E6000 or Goop. Amazing stuff. I'll put a link below if you want to pick some up. This is like the, I call this the duct tape of glues. It sets up, it's meant to like repair skater shoes. Like the bottom of your shoes you wear out because you skate too hard. that's what it was kind of meant for, and you can rebuild the entire bottom of a boot with it, and it holds up amazingly well. But put it in there, it stays barely flexible, but it bonds so well, the plastics, everything else, rubbers. Anyway, we have all of our leads soldered up on here, and I put a little shoe goo in between each one of these wire connections as well, just to hold them firm. It'll kind of set up like the white elastic snot stuff they put on circuit boards and stuff like that to keep them from vibration, from ruining them. And just start feeding my wires up through them. Pretty basic. This would be the perfect thing if somebody had a 3D printer. Hey, if you have a 3D printer and you want to print me out a case, that would be awesome. And we'll just pull that up. And we'll just flop this over and make sure that's going to be all the way up. Get all the metal filings and stuff off my workbench, off of that. We'll attach this. Now we can screw this together. We'll just put a screw or two in it real fast. And shout out to Dewalt for this. This is an amazing... I know this isn't the subject, but this little screwdriver I did not expect. I just picked up a little screwdriver because I was doing a ton of electrical outlets and stuff like that. Did not expect this when I got it. Pull the trigger. Okay, I'll pull the trigger. Doesn't move. It senses the rotation of your hand. It's gyroscopic. And the more you turn it, the faster it spins. So cool. Just pull the trigger. Turn your wrist. And it turns the way, just like if you were going to screw a screw. Amazing. Shout out to Dewalt for that one. I didn't know it did that when I bought it. There we go. The final positive wire. See, I have all the balance leads tucked in. No blow up. Good. So now I just have to connect. These are my own wires. I installed a battery meter myself. I have a whole video on how to install a battery meter on batteries that don't actually have one. You know, a lot of times you buy these little cheap, smaller batteries, and they don't have meters on them. And I show you how to put these meters in them. So I'll rehook up this meter, and then we'll be able to see what the charge is and be able to try it out. My angle grinder, this is what really just eats batteries. I run these same battery, these 4 amp hours in the Makita and grinders. But this brush, this one isn't a brushless one. Actually, it's still front heavy. Really doesn't feel that out of balance. Feels like a big old battery pack. I guess let's see if we can stall it out. Let's see if we can really get double the amperage, because I can stall out a 4 amp hour battery pack with this Makita. So we'll throw it in here and we'll see what we can do. We'll see if we can make some smoke fly. Wow. Wow. That has a ton more power. Yeah, it easily has twice, the tool has twice the power because it doesn't hit that low voltage shutoff. Awesome. There you go. Looks like a battery pack. It's a little bit bulky, I'll give you that. Twice as heavy as just a single, but it's about the same weight and size if you actually go to the store and you look at one of those 12 amp hour packs. So, you know, those might be a little fatter, a little longer, but, you know, so this one's a little bit skinnier, narrower, so, but it's about the same weight because I've held those before. It feels about the same. This one might be, maybe it's a little bit heavier, maybe not. I'd have to look that up, but for something like this, you get easily double the power because this, you know, this 4 amp hour that is able to put out about 30 amps is now 8 amp hours, but it can put out 60 amps. So I double my amperage that the tool can use. So it's much happier. It's much easier on the cells in here. The cells will actually last a lot longer because you're not stressing them out. You could do the same thing. You take two, you know, 5 5 amp hour Makita or Dewalt or Milwaukee, and you can make a 10 amp hour out of a pair of these. This turned out awesome. Can't even really tell. You'd pick up this battery pack and you wouldn't even know that anybody did anything to it. This one actually turned out really slick. It'd be really cool if I did another set and made this into an 8 amp hour, you know, versus just a, you know, a 6. But now I've got 2 bigger packs. You really can't even tell the difference weight-wise because I only added 3 cells. Can't even really tell. I'll put links below in the video description to everything I talked about. Details, if you want to know a little bit even more about the batteries and stuff, I'll put all that in the description below. Links to stuff that I use. But thanks for watching, guys. Hopefully you guys enjoyed that. Comment below. See you guys soon. Bye. Hey, I'm getting thirsty. Can you give me my drink? Can you put it in my hand? Oh, good job. Thanks, puppy. There you go. Hey, just leave it. Hey, get up there. Hey, I'm getting thirsty again. Can you bring me my drink? Where's my drink? Bring it here. Bring it here. Oh, that's a little rough on it. Oh, I dropped it. My bad. Oh, my bad. Give me my drink. I don't got it. There we go. Good job. Oh, you're a good sport. Hey, get up there. Tell everybody goodbye. Get up there. Good job. See you guys soon. Right? Where? Where are they? They're right there. See them? Right there.